Hello, welcome to the review of the new features and changes that Xilinx has made to our embedded software environment for the 2019.1 release. In this overview, we'll start by discussing the version updates that Xilinx has made to our embedded software stack as well as our development tool chains. Next, we'll spend some time covering updates happening throughout the embedded software stack, including some exciting updates for the Zynq UltraScale Plus MPSoC Multimedia stack. Finally, we'll close out by discussing updated support for Zynq UltraScale Plus RFSC and MicroBlaze. For our embedded software tools, we've adopted the GCC 8 series of cross-compiler toolchains for all of our development targets, from MicroBlaze all the way through to Zynq UltraScale Plus devices. We've also updated our build environment support to include Yocto 2.6.1, codenamed THUD. This has a direct impact on the host OSs that we can support, as we'll discuss in just a moment. On the Linux front, we have updated our Red Hat and CentOS support to include versions 7.4, 7.5, and 7.6. For Ubuntu users, we can now support Ubuntu 16.04.5 LTS as well as Ubuntu 18.04 LTS. The ability to support Ubuntu 18.04 LTS comes directly from our updated Yocto infrastructure. For users of Zynq 7000 devices, the Linux build environment can now handle device tree overlays natively. This is a useful feature for designers who require the ability to swap out bit streams at runtime but need to specify this architecture during their system development. Linux 2019.1 includes a BSP for Spartan 7 based SP701 boards. This BSP includes initial support for all of the general purpose board interfaces. The Linux 2019.1 release also includes a BSP with improved capabilities for the ZCU 1275 board. Specifically, this BSP adds supports for Ethernet connectivity via an optional FMC card, as well as TFTP boot support in U-Boot. This support will ease the development workflow for designers using this board. In recent years, Xilinx has made a concerted effort to keep our software stack as close to the leading edge of upstream projects as possible, while also providing users with a steady release cadence. We accomplish this by adopting a new software release version at the beginning of each calendar year and perform incremental updates over the subsequent 12 months. This procedure continues in 2019. Starting at the most fundamental level, we have updated our ARM-trusted firmware support to version 2.0 for users of Zynq UltraScale Plus MPSoC and Zynq UltraScale Plus RFSoC. U-Boot support has been moved to version 2019.01 for all devices ranging from MicroBlaze through to Zynq UltraScale Plus families. For users of Zen Hypervisor, we have upgraded our support to version 4.11, which includes some exciting improvements that we'll discuss a little later. Linux kernel support has been upgraded to version 4.19 LTS across all microprocessor targets. It is all tied together with support for Yocto 2.6.1 as previously mentioned. In the realm of bootloaders and firmware, we've made some exciting progress. In 2018.3, we introduced initial support for dynamic DIMM SPD data usage on ZCU 102 and ZCU 106 development boards. In 2019.1, we extend the support to users using Vivado. To use this feature, simply set the tickle parameter highlighted here in your Vivado project. This setting then overrides any settings found in the Processor Configuration Wizard GUI and passes the correct information into the FSBL code. On Zynq UltraScale Plus devices, the PMU firmware code has begun safety assessments that will continue into the summer of 2019. Currently, this code is targeted for use in applications of the ISO 26262 ASIL-C standard and SIL-3 applications under the IEC 61508 standard. For more information, please check the Functional Safety Lounge on Xilinx.com linked here to request access. With the update to version 2019.01, U-Boot has received several key enhancements, including support for USB 3.0 host operation and I2C multi-master mode. In addition, SHA and RSA operations can now be performed within U-Boot using the ZIL Secure Acceleration library. Finally, we have added support for several new ISSI flash devices as seen in the table on the right. For Zynq UltraScale Plus MPSoC and Zynq UltraScale Plus RFSoC devices, our ARM-trusted firmware support has been upgraded to version 2.0 as highlighted previously. This updated ATF support includes new capabilities such as the ability to perform checksum verification on interprocessor interrupt or IPI messages, improved API support for checking the clocking infrastructure, and additional runtime detection of the target device. As has become the norm, Xilinx has updated and improved our multimedia framework stack yet again for the 2019.1 release. Of particular note is our support for up to 32 simultaneous encode and decode streams at the 480p resolution mark. In addition, we have added support for dynamic resolution change for both encode and decode streams inside the VCU. This allows designers to dynamically change from a higher resolution to a lower one and then back again in order to efficiently balance bandwidth and frame rate requirements. Finally, we've added support for DCI 4K mode in the -2 and -3 speed grade devices. Moving on to talk about our updates in the realm of RTOSs and bare metal libraries, Xilinx continues with our commitment to these domains. For FreeRTOS users, we have updated our support to include FreeRTOS version 10.1. This update brings with it XSDK GUI support for configuring the newly added stream and message buffer communication primitives inside of FreeRTOS. On the library side, we have updated our support for LWIP to version 2.1.1. This brings with it some important updates that fix issues related to TCP overflow conditions and the LWIP sockets interface. These updates apply to all processor targets including MicroBlaze, ARMv7 Cortex-R, ARMv7 Cortex-A, and ARMv8 Cortex-A. For multiprocessing specific use cases, Xilinx continues our work on both heterogeneous multiprocessing in OpenAMP, as well as homogeneous multiprocessing in Xen Hypervisor. For OpenAMP users, Xilinx has added support for libmetal and OpenAMP to support the Cortex-R processors as a multiprocessing master. This update now allows the RPU to deploy a binary to other processors in the system rather than limiting OpenAMP master support only to the APU. For Xen Hypervisor users, Xilinx has now rolled out official support for DOM zeroless operation for rapid boot scenarios. In addition, Xen Hypervisor has also gained support for EMI-based power management on a per-device basis. This power management infrastructure can be controlled within the DOM you guessed rather than requiring these mode changes to be proxied through DOM 0. The big news in the world of MicroBlaze is the official public release of 64-bit MicroBlaze support. As was seen in the preview version, this update allows MicroBlaze to address a full 64-bit memory space while retaining support for existing 32-bit binaries. In this public release, users will find integrated support inside Vivado, XSDK, the system debugger, and the GNU cross-compiler toolchain. In addition, the bare metal and FreeRTOS BSPs have also been updated to support these new capabilities. For users of the Zynq UltraScale Plus RFSC family, the 2019.1 release brings Vivado and runtime software support for the Zynq UltraScale Plus RFSC Gen 2 and Gen 3 devices. In addition, the Zynq UltraScale Plus RFSoC devices now have support in a variety of Xilinx tools, some made just for them, including the RF Data Converter Evaluation Tool, the RF Analyzer, and the Zynq UltraScale Plus Power Advantage tool. Software developers using these devices will find that the Zynq UltraScale Plus RFSoC software stack now includes API support for toggling dither on data streams. In addition, the SDFEC now has a proper Linux kernel driver, and Xilinx has begun the process of upstreaming these drivers into the mainline Linux kernel. To recap, Xilinx has updated our SoC software infrastructure across the board to keep pace with the industry and the ecosystem around us. We've also made key enhancements to our multimedia stack to allow designers more flexibility when handling multiple data streams. 64-bit MicroBlaze is now available for all users, and the Gen 2 and Gen 3 Zynq UltraScale Plus RFSoC devices are now integrated throughout our design tools and software stack. For a full list of all of the changes present in the 2019.1 release, please take a look at document UG973 on Xilinx.com. To download our tools such as Vivado, XSDK, or Pedalinux, please go to Xilinx.com/download. For access to all of our open source collateral, including the Linux kernel, U-boot, and our bare metal software stack, please look on our GitHub page at github.com/Xilinx. For access to example designs and other technical resources, please visit our wiki located at wiki.xilinx.com.